Okay, I'm going to make the assumption that you've watched the other videos on the MathCad basics on how to do some entering numbers in text and the equal signs and things like that. So if you haven't done so, please do that already. And just a reminder is that MathCad is recommended for the civil engineering, environmental engineering, and the chemical and metallurgical engineering students. And for the double E and the mechanical engineering students, it's recommended you complete the MATLAB assignment. Now, it's your choice as a student whether you rather do MathCAD version or the MATLAB version of the assignment, but you have to do one of the two. That's just our recommendation because of what software the departments tend to use when you get to later courses. So first I got a text box here. It is my name. Of course, you can put in your name and your real team number and your section number, and then of course this is the same for everybody, lifting fan calculations. As it says here, all this text in the red is my comments to you, so you don't need to include that in your assignment. So this is a text box area of a hovercraft, and I've typed in a formula here, or just a number basically, area. So I'm going to retype this just to make sure we remember how to do this. I'm going to type in here, I'm going to say area, and I'm going to use the semicolon, or sorry, not the semicolon, the colon. So colon 576 inches, and then you use the little caret, that's shift 6. Caret raised to 2. So remember that MathCAD understands units, so we can specify them. So 576 inches squared. That's basically the example for a 24 by 24 inch hovercraft. So that's basically the way we enter a number. So that's what we're defining. So this little colon equal sign, you get that by typing the colon, just shift colon. And that's covered in that other video. So that's how you define something. Okay, so then I got a gap area. Again, this is a text. Perimeter length. Again, it's the example from the square hovercraft, so it's 96 inches. I just entered this. This is something I typed in. Gap height. And remember, this is kind of a holdover. If you can't use spaces and names, so you have to use these underscores. So gap height was the 0.2 inches. We talked about that in the lifting fan lecture. And then here's a calculation. So the gap area equals the perimeter length times the gap height. It's hard to see the little times there, but it's a times gap height, and you get 19.2 inches squared. Actually, you get something a little bit different. Let me show what you get when you first type this in. If I say gap area and I say gap area equals, I'm asking what the gap area is, and it tells it to me meters squared, because that's the default units, but I don't want it meter squared, so I'm going to type in this little placeholder box. Lets me redefine the units or request in different units. So I can say inches raised to 2, and now it'll give it to me in inches squared. So MathCAD's pretty easy. So for example, maybe I didn't want inches squared, maybe I wanted feet squared. I can go ahead and ask for feet squared, and it'll tell me in feet squared. Or if I wanted in centimeters squared, I could ask it in centimeters squared. You can ask it for whatever units you want, and it actually converts the units for you. That's the big beauty of MathCAD, is that it knows units and understands units. So we want it inches squared because that's what we're going to be using later. So there's 19.2 inches squared. So let's scroll down here. The weight of all the components, I've entered all these things. Now, MathCAD's got a funny thing because it thinks pounds is a mass, which as a mechanical engineer that drives me crazy, but because a pound is not a mass. But so you have to use LBF, which stands for pounds force. That's just one of the things we have to talk about. So pounds force. And so lifting fans, and this is all from the lifting fans example. So I just entered all these things, which was the tabulated values before. And then when I get the actual weight, I wrote a formula that adds all these things up. So of course, if I change anything, and the spreadsheet was great, if I change anything, like I changed it to 0.4, everything changes. So at 0.23, 3.23 became. So this is like a spreadsheet in some ways, and it's live updating. But it's a little more complicated because it handles units and things like that. So just like in the example we had in lifting fans, so I actually write the equation here, and then I ask it for what the actual weight is, because here I define the equation, then I have to ask it to actually tell me what that number is. So it tells me it's 3.03 pounds force. It says weight. But of course, we add a little bit of wiggle room here, as my comment mentions. I add a little bit of wiggle room, and I'm going to use 4 pounds because that gives me a little bit extra in case there's some duct tape and things like that, extra batteries we might need. And then we go into do our pressure and flow rate calculations just as we had before. So the required pressure, prereq, is the required pressure is the selected weight, which is that 4 pounds divided by the area. And again, but by default, it gives it to me in something really strange in pascals, so I actually just typed in PSI, so I want it in PSI. Now, I also want it in inches of water, and it doesn't know. That's one of the, remember, this is an ancient unit of pressure, and it doesn't quite know what it is, so I actually had to define it. So I typed in this definition, inches of H2O equals, and I use that colon for the equals, that's a definition, 1 over 27.68 PSI. And then I can ask it. So later on, when I said, if I go in and asked it, whoops, so let's read, I'll show you here what I did. I said prereq, and I asked it for a prereq, and it gives it to me, 47.88 pascals. But I don't want it in pascals. I want it in this new unit measurement, so I'll ask it to give it to me in inches of H2O. And it goes ahead and converts that to inches of H2O. Because I defined a new unit here, so now it knows what it is. Okay, and I'll need that, of course, when I go to my data sheet. All right, so then I can do the leakage velocity, or that V2. Sometimes it's called V2, sometimes it's called VL. 2 times G. Now it knows what G is. It knows that's the gravitational constant. So I don't have to define the units or tell it what it is. It knows what it is. In fact, if I ask it for G, if I just type G equals, it'll tell me what it is. It tells me it's 9.807 meters per second squared, which we all know is G, 9.81 basically. Okay, Prec, that's the thing I just calculated here, divided by this gamma, which I type in gamma, which is the pounds force per cubic inch, the specific mass, specific weight, sorry. And I ask it, of course, what VL is. Once I've defined VL, I have to ask it what VL is. Just to remind you the way that works, right? So VL, I've defined that equation here, and then of course I don't know what it is. I can go ahead and use it, VL, but I want to know what it is just because that'd be useful information. So I do V. Oops, a capital V, sorry, capital V in this case, and then to get a subscript I use the period, so period L, and then I say equals. Whoops, I forgot the equals sign. Type in equals, and it gives it to me in meters per second, which I don't like because I want inches per second. So I'm going to go ahead and say in here, I say inches per second, and of course it gives me the 348.68 inches per second. Okay. And then, of course, I calculate my Q, so I get VL times the gap area, which we defined earlier, and I get 232 cubic feet. It gave it to me actually in cubic meters per second, but I had to retype it into just cubic feet per minute. So it tells me 232 cubic feet per minute. Now it's great. Now I'm done with this part of the whole thing. So I go in there and I say, okay. And I go in here and I've got to pull in my my data sheet. So I go and I open up my data sheet here, and my data sheet tells me a couple things. It tells me this graph basically, and so it tells me I need at 0.192 inches of water, which is this vertical axis here. I come across and I read across. I see what intersects my curve, and I come down, and it tells me it's about 95 CFM. So if I were to draw a line here across and where it intersects, it drops down to about 95 CFM. So that's the CFM I can get at the desired pressure. And so I need 232, and hell, I can get 95 per fan. So that tells me that I need 3 fans, is what that tells me. So that's going to be necessary for the second step. The other thing that's necessary for the second step is I need to calculate the battery. So I know I need 3 fans to do this, which is what the example was. I'm going to scroll back up through all this stuff here, and I got to find somewhere in here where it tells me how many amps this fan is supposed to draw. So it tells me the rated voltage is 12 volts. Operation goes from 10.8 to 13.2. So if you go above 13.2, you can let the magic smoke out, and you go below 10.8, it's probably not going to run correctly. It probably will run, but not correctly, maybe too slow. So the input current, there it is, 1.15. So 12 volts DC, this thing is supposed to draw 1.15 amps, or 13.8 watts, basically. So 1.15 is the nominal current. Now, again, it may not actually draw that much. It's actually telling you 1.7. If you looked at the fan, it'll say 1.7 on the fan. But this case is actually telling you the nominal, so it's telling you that 1.15 is really what it'll probably draw. So stamped on the fan is 1.7, but in reality, if you test it, it'll probably draw 1.15. So 1.15 amps, I'm going to need that. Because I have 3 of those fans, so I need to know how many amps I'm going to draw here. Okay, so that's the first part. Now I'm going to go over, I'm going to enter my second one here. So here's my second worksheet. I'm going to do the battery calculations. Again, I've got my name in the text box here, and now I'm doing battery calculations. So I have a number of fans required. That's 3. I just found that out because, remember, I had 232 CFM I needed, and only 95 per fan. So I need number of fans 3. So I enter this number. The current per fan, that was what I was just talking about. So we have 1.15 amperes is the current that each fan draws. So the total current required is just the number of fans times the current per fan, because our fans, remember, are in parallel. Don't do fans in series. So fans in parallel, that's 3 times the total, since they're all the same. So that gives me 3 times 1.15, which is 3.45 amperes. So this will definitely melt a plastic battery pack if you try and draw 3.5 amperes out of plastic battery pack. Okay, so that's the total current required. The minimum capacity required, well, that's the total amperage times the time I have to run. This is where MathCad's kind of nice because it does units. So I multiplied 3 minutes because my hovercraft's got to run 3 minutes times that total current required, which is that 3.45 amps. And so it gives me something. I'll undo this here so you can see. Oops. So when I ask it what that is, if I just say minimum capacity required, it gives it to me in coulombs. Remember we talked about this. Coulombs is actually a unit of capacity. So it actually gave me coulombs, but I don't want coulombs because that's kind of silly. What I really want is I want milliamperes times hours. I want to know what it is in milliampere hours, and it converts it to me. So I need 172.5 milliamperes per hour. Now, most battery packs that you buy are like 2,000, right? 2,500, 900, so it's way more than we need. Of course, you got to keep in mind that this is for the 3 minutes. Right? This will get me through the competition, but of course it won't allow me to test, won't allow me to practice. So for example, now this is a great design tool because let's say, okay, I need it at minimum 172.5, but actuality, when I want to test, I want to be able to test for 25 minutes, let's say. So I can type in the number 25 here, and guess what? It's going to tell me how many ampere hours I want. So now I got to have 1,400 milliampere hours. Okay, so it's telling me exactly what I want. That's for 25 minutes of testing. Well, maybe that's a lot. I only want to say, I only want, to run 12 minutes. And of course it updates again. Now I only need 690 milliamp hours. So this 3 minutes is the bare minimum you need, but you can actually type in the numbers here and find out how long will actually run. Now maybe you buy your fans and you test it out. And, hey, my fan's only drawing 0.95 amps. I put in here 0.95 amps. You have to update. It'll tell you how long your battery pack's actually going to last. So this is going to be a design tool for you in the future to actually decide what battery pack you want to use, how long you expect it to last, things like that. Okay. So that's basically, in a nutshell, what you're going to be doing. Now, if you look at the written assignment, you're going to be changing some of the numbers. We're going to change some of the weights and some of the things like that for you, so you'll actually get a different number of fans required. You'll be using the same fan here for the current, but you're going to use a different number of fans, and so you'll get some different numbers here. So make sure you go ahead and read the written assignment now and see what numbers are supposed to change, and complete the homework assignment and submit that.